Now today we will start signal and system for BEL preparation. Okay. Sorry guys. Today we will start signal and system, and that subject also covered in the similar way like network analysis. Okay. All the important things we write here, that is the in handwritten format, and theoretical things we covered with the help of PPT, so that in the prescribed time format we covered each and every topic. Okay guys, in network analysis any problem? Are you comfortable beta in the network? Tell me. Anil, Anshu. Okay Anshu. Okay beta. Now today is the first lecture of signaling system. So first of all we discuss the syllabus of signaling system according to BEL. Okay. This is the subject, signal and system. Signal and system. Signal and system. See beta, chapter number 1. In chapter number 1 we covered introduction, and basic operation, basic operation, basic operation on signal, on signals, not on system, only signals. Next beta, in second chapter we covered important signals, like impulse and unit step, parabolic, signum function, all beta. Next, other classification, other classification of signals, like energy signal, power signal, periodic, non-periodic, causal, non-causal, and so on. This is the chapter beta. Next, in fourth chapter we discussed about system. What is systems and properties and its properties and its properties. Next, fifth chapter. In fifth chapter we discuss CTFS. CTFS means continuous time Fourier series. Here we explain what is the difference between the continuous and discrete in the first chapter. Okay, so wait for this. Next chapter we discuss CTFT. CTFT, that is continuous time Fourier transform. Seventh chapter is DTFT. DTFS, that is discrete time Fourier series. Next, in eighth chapter we discuss DTFT, discrete time Fourier transform. See beta, CTFS means continuous time Fourier series, continuous time Fourier transform, discrete time Fourier series, then discrete time Fourier transform. Next we discuss Laplace transform. Okay, Laplace transform. And in this 10th chapter we discuss Laplace transform, Z transform. 11th chapter sampling, and in 12th chapter we discuss miscellaneous topic. Okay, miscellaneous topics like fast Fourier transform, okay, and discrete Fourier transform, comma, filters, etc. Okay, these are the topics of signaling system. See beta again. This is the complete syllabus of your BEL preparation or any other PSC. Okay. Only here we discussed all the topics, but level is maintained only BEL like PSUs. Okay. See beta, introduction and basic operation, important signals like unit step, impulse, parabolic, signum, etc. Next beta, other classification of signal like power signal, energy signal, periodic, non-periodic, like that. Okay. Next, system and its properties. Next beta, CTFS full form, continuous time Fourier series, continuous time Fourier transform, discrete time Fourier series, discrete time Fourier transform, Laplace transform, Z transform, sampling, miscellaneous topics like Fourier fast Fourier transform. DFT means discrete Fourier transform. But this discrete Fourier transform and DTFT, discrete time Fourier transform, both are different. Okay. See, and filters like IIR filter, and what is the properties of that filter. Very good evening, Anshul. Okay, next. But this is the syllabus. Okay. So all the guys who are connected late, okay, this is the syllabus, and only up to here we discuss syllabus. This is the syllabus beta, your signal and system. So proceed. And any other doubt for you guys, your, okay, tell me, related to signal and system. Any other topic, if you think sir that topic are left by you. Sorry. Okay, so these are the topics beta. So we discussed first chapter. Okay, first chapter. And beta, you not need to write anything. Okay, here all the points related to each and every topic and concept, okay, we write here or we covered with the help of PPT. See, first chapter. First chapter, if speed is high, then please write in the comment box. Okay. See, first chapter, introduction, 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 and basic operation, basic operation, basic operations on signal, on signals. Introduction and basic operation on signals. See, what is signal? Anyone tell me what is signal? What do you understand by signal? Tell me beta. Come on audio feature so that it take less time. Anybody know? Anything? Anything which contain any information. Yes beta, carries information. Yes beta, yes, which contains some information. Yes, you are right beta. See, 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 anything, anything which contain, which contain, which contain information, information is said to be signal. Okay, signal. Okay beta, this is the basic definition. But mathematically, 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 signal is a function, function of one or more independent variable, independent variables, variables. Okay. See, what is the role of independent variable? See clearly. If we draw the point, because next point is the sub point of previous point, so we represent like this. If independent, here we discuss one example of that definition, like y equal to x of t. It means y is expressed in terms of t. Then here, independent variable is t. This is independent variable. Independent variable, like y equal to fx. In y equal to fx, x is independent variable, y is the dependent variable. But in terms of signal system, we express y is a function of t, or we said to be here time is the independent variable, and this is the example of continuous time signal. Okay, and what is the difference between the continuous time signal and discrete time? This is clear by me in the next slide, but here we clear the definition. Mathematically, signal is a function of one or more independent variable. Here we consider one example. Independent variable here time, and y is the dependent variable. Dependent variable. Okay, dependent variable. So see beta, next, if, see, if independent variable, if independent variable is only one, then this signal this signal is said to be is said to be bolo beta, what is, put in the fill in the blank. Tell me, if independent variable is only one, then this signal is said to be. Tell me, if you having any idea related to this, tell me beta. If in any signal representation, independent variable is only one, either time or space and so on, then see, any student, no, see, said to be one dimensional, one dimensional. Otherwise signal is said to be multidimensional. Okay beta, see, if independent variable is only one, then this signal is said to be one dimensional. If otherwise signal is said to be multidimensional. See the example of multidimensional one dimensional signal. See beta, example 1 here, y equal to x of t. Y is the function of time. See, equal to 2t square plus 1. This is the representation of one which containing only one independent variable, and here independent variable is the time. See next, this is the 1D signal. Because here independent variable is only one. Next example 2, y equal to x t and small p. Here independent variable more than one. So this is the example of multi-dimensional signal. So here we write like 2t square p plus p square. Okay. So this is the multi-dimensional multidimensional signal. Okay guys, tell me beta, up to here in any point, tell me beta, what is the signal? And this is the theoretical definition, this is the mathematical definition. Here we clear the difference independent and dependent variable, and this is the basic approach beta. And this is the beta one dimensional and two dimensional or singles. Here we clearly differentiate between one dimensional and multi-dimensional signal with the example. Tell me beta, up to here any doubt? Anshu, Shodhan? Okay beta, okay. See, this is the basic introduction beta. This is the basic introduction. Next, then here we introduce the system and basic approach. But when we discuss in detail the chapter system and its properties, where we discussed all the relevant properties, linearity, convolution, which is the important property. Okay, but here we only discuss the definition because signal and system is our subject, and today is the first chapter. So first of all, we discuss the introduction and importance of that subject and why we study signal and system, where we use signal and system subject as a application. Okay guys, see. Next, system. System is a, tell me beta, what is the definition of system? It is a group of devices which operate on signal. Yes beta Deepika, you are right beta, you are right. System is a interconnections or combinations of physical components okay, that convert one form of signal into other form. Okay beta, other forms. Okay, this is the basic definition and this is the representation. Like this is the system, any general beta block diagram. This is the system. Here we apply the input and here we get corresponding output, and depending upon the system, this input converted into, depending upon this box system, input is converted into output. See, here we represent input we denoted as this, or beta excitation. This is the input or excitation, and corresponding to that input or excitation, this system generate output. This is the output or response. Okay guys, this is the general symbolic representation. How this system perform tasks, this is not our agenda, because in the black box which component is connected, this is not the role of signal and system. Okay guys, this is the role of digital system like ADC, DAC, combinational circuit, sequential circuit, because in digital electronics we design any logic circuit. Okay, like multiplexer, demultiplexer, adder, subtractor and all. Then this is the purpose of designing of any system we read in digital electronics. But here we only read or study or understand the any system perform the function on the signal. Okay, and according to input or excitation, it generates some specific output or response. This is the meaning of system. Guys, tell me in the comment box. If you having any doubt, tell me in the comment box, or come on audio feature also. so that we use that feature in fruitful way. Vaibhav Raj Singh, okay sir, clear hai sir. Okay sir. Okay guys. This is the beta basic meaning. Now we discuss, sorry, we discuss continuous time and discrete time signal. Basic approach only in rough language only. See, because the teaching is the way in which you understand easily any concept. See beta. Now, note, note, note one. General representation, general representation, representation, representation of signal on the basis of, on the basis of independent variable, independent variables, okay, or nature of the response, nature of the response. But this is my concept, not a standard or any other. This is my way for teaching, and this is the general flow of lecture. Okay, see, this is the general representation or nature of response based on the nature of response. See, number one, beta, number one, CT signal, CT signal, CT signal. What is the full form of CT? Continuous, continuous, continuous time signal. Continuous time signal. What is the continuous time signal? See beta. See, here we consider, sorry, first of all, representation. Representation. Okay. Representation. One mathematical approach we use. Actually, when we move in the next chapter or portion in the signal and system, then we discuss how many types of signal representation. But here we use the representation of any signal on the basis of response. See, representation is y t equal to some 2t plus 1. This is the one example, beta. We draw this. We draw this example. Like, beta, compare y equal to mx plus c. Compare y equal to mx plus c. This is the y and this is the time. Then this is a straight line with a slope of 2 and intercept of 1. Then this signal is like, and intercept is positive. So this signal pass through this beta. Okay. This is the beta intercept because intercept is positive and this is the value is 2. And what is the, sorry beta, this is the intercept, that is 1, y equal to mx plus c. Okay. See. This is the intercept 1 and this is the beta slope. Okay. This is the slope. Slope is 2. Here we consider one general example. See beta. If this signal is beta from, what is the range of that signal? Minus infinity to plus infinity. Okay. See beta. In this side, it move in the negative axis and in that direction, in positive direction, the range of that signal is the minus infinity to plus infinity. See. Beta, this signal is defined for each instant of time. Then this signal is said to be continuous time. See, if any guys think, sir, any signal that contain each possible value of time, then this is said to be continuous. No beta, only that signal particular. See, we consider another example so that your concept will be clear. See, this is the one example representation. Next beta. Next, other example. Other example we are consider yt equal to 2. Yt equal to 2 when time time is less than equal to 2, less than equal to minus 2, and greater than equal to minus 2, and less than equal to 2. Okay beta, and this is the constant value of the signal. See beta, we plot that signal like this. Minus 2, this is the origin, like this is the y, this is the time. See, this is the simple way beta. See, this is minus 2, so we consider minus 2 here because this is origin in general, and this is plus 2. Okay, see, value is 2, we consider here 1, here 2, so value is 2, so we draw like this, and this is the value of signal 2. Okay beta, this. But in this, between the minus 2 and plus 2, signal contain any possible value of the function. Here is the constant value like 2. Okay, if we consider another example beta, y equal to in general xt, and plot of xt is given like this, and but this is the time t2 and this is the time t1. So between the time, if xt is the general shape which follow that curve, then between t1 and t2, xt having some finite value. Okay, see here, between minus 2 and 2, at yt having some finite value. If signal having any finite value or any value between the range of the time, then this signal is said to be continuous time signal. Okay beta, see, here we draw some conclusion. Any signal in which value of that signal is exist for the defined range. Okay beta, defined range. Tell me beta, this definition is clear or not from these example? Any signal beta in which value of that signal is exist for the defined range. Okay, if this signal is defined for minus 2 to 2, then what is the value of 5? 0. So in that particular example, we can't say that CT signal is that which occupy all the values, or we can say CT signal is defined for each value of time. No beta, only defined range. In defined range of time, signal occupy all possible values. This is the definition. Tell me beta, this is clear? Anshu, Darshi and clear na beta? If any doubt, please tell me and come on audio feature and discuss with me. Okay, this is the simple way beta. In the defined range, this is the defined range of general signal, like y equal to x of t. So this is defined between the time instant t1 and t2. So when we put any value between t1 and t2, then corresponding to that time, signal having value. Okay, see, in this question, between minus 2 and 2, if we put any value, but in this question, the value we achieve constant, which is 2, because between the minus 2 and 2, signal having constant value. This is the example of constant function or constant signal. Okay, this is the beta clear or not? Continuous time signal is clear or not? This is the beta our first representation on the basis of response, because here we achieve response in the given range, and in the range at each instant of time we get some specific value in the defined range of time beta, like this. Okay, next, DT system, DT signal. Second is dt signal, dt signal. See beta, dt means discrete beta, discrete, discrete time, discrete time signal, discrete time signal. Here we consider first of all one example. Okay, example beta, y equal to, see here we draw one waveform. This is the n. Here the independent variable is time, but here time is expressed as small n. Okay, see, this is the way of differentiate between the continuous and discrete time. What is the basic meaning of discrete time signal? See beta, like this is the y, and here we plot y equal to x. Here we use square bracket, but in our curriculum we use small n bracket, but actual we represent that. When we write x in bracket small bracket n, then this meaning is that x square bracket n. Okay, see, here we plot one graph. See, this is the instant n equal to 1, and this is the n equal to 0, n equal to 0. See, this is the n equal to 2 beta, n equal to 2, and here we denote the value of y corresponding to that instant. This is the value 2, and this is the value 1. See beta, see, this is the example. Here we denote one bubble, solid bubble. See beta, in that example, at n equal to 0, the value of the function is 0. Okay, but at n equal to 1, the value of the function y, value of the signal 2. Okay, next, at n equal to 2, the value of the y is the 1. But between n equal to 0 and 1, what is the value of the signal? See again, between n equal to 0 and n equal to 1, what is the value of the signal? Can't define. Okay, can't define, or 0. See, between n equal to 1 and n equal to 2, the value of the signal 0. When signal is present at a particular value of the time, then this is said to be discrete time signal. Okay, is it clear or not? Tell me beta, this is clear or not? See, so if any signal is exist at a particular time instance, then the signal is said to be discrete time, dt signal. Okay beta. Next beta, between any two successive time instants, signal is not present. Okay beta, see, in this beta, if we say between two between two time instants signal is absent, this is the not correct. See, between n equal to 0 and 2, signal is present now, but any two successive time instant, like in this example, n equal to 0 and n equal to 1, this is the basic representation of any signal, and between where we consider two successive time, that is n equal to 0 and n equal to 1, between n equal to 0 and n equal to 1, signal is not present. Okay, this is the basic difference. Here time is the discrete, or we can say in the integer multiple of natural number or whole number. Okay, because here 0 also consider. So here we use time is the integral multiple of 1. Okay beta, or clearly say discrete in nature beta. 1 is not the wholly fully correct answer. Okay, clearly beta, here we correct myself integral multiple of integer beta na, or in the form of integer or in the form of discrete beta. Okay, this is the basic meaning. Yeah, here we discuss only the basic things. Next, basic approach operation, basic operation. Now basic operation, basic operation on signals beta. This is our second part of that chapter, basic operation on signals. See beta, here two variable, one is independent and other is dependent. Separately we discuss both the variables in both the representation. Like continuous time signal, we consider both the operation, like operation on dependent variable and operation on independent variable. In similar way, these two operations we discussed on the basis of discrete time signal. Okay, so beta, in the above content, any doubt, tell me. If in any point, if you having any doubt, then tell me, so that next point we covered with the help of PPT. Okay, tell me beta, any doubt? Anshul, Anshika, Meghna, tell me. Seven message, Shodhan, Harshini. Okay beta, now next. Okay, next beta, operation on continuous time signal. See beta, and here we maintain speed so that you understand each and every point beta easily. This is the beta. See, this is the heading operations on continuous time signal. Okay, on what type? Operation and operation on dependent variable. This is the on, not and. Okay, operation on dependent variable. See beta, if y equal to x of t, then dependent variable is that na. So here we perform all the operation y. See, simple thing, amplitude scaling. Consider an example, not read the typing format. See here beta, if this is the signal beta, this is the signal y, this is the time. If we draw that signal, this is the 0 and this is the value of time, that is 1, and this is the value of the signal, like 2 beta. From 0 to 1, value of signal is 2. If this is the y beta, this is the y equal to xt, y equal to xt. If we want to draw y equal to 2xt, then this is the scaled version of y, scaled version, and this is we set to be y1, because y equal to xt, then new function y1 equal to 2xt. How we can draw that? See beta, this is called scaling property, sorry, amplitude scaling. Okay, see, if in any function we multiply some scalar, then all the values on y-axis multiplied by same scalar. See, if we draw y1 equal to 2 times of xt, then graph become, this is 0, this is 2. On the time axis, value are same. This is the y, so this value becomes this. And 2, this is the 2 into xt, and xt graph is that. Then what is the 2xt? We multiply all the value on y-axis by same scalar, that is 4. This is the beta meaning of amplitude scaling. If we want to draw half xt, we multiply by half in xt. Then what is the result? We multiply y-axis y1, y2. Which value occupies by the y-axis? We multiply whole the value by the same scalar. Like here by 2, if we consider 1 by 2 xt, then we multiply all the value which lies on the y-axis or on the value of y or on the value of amplitude. We multiply same scalar. Okay? See beta. If here beta y equal to, here we consider some example. Okay, this beta y equal to axt. Here we consider some example. Okay, if this a means mod of a is greater than 1, then yt is amplified version of xt. Why amplified? Because we get magnitude higher than the original. See beta here compare that to function y equal to axt. Here a is the 2 which is greater than 1. When we perform that function on that signal, then we get amplified version of that signal because amplitude is amplified or increases by two times. See here. Okay. That's why this is said to be amplified version of xt. If mod a is less than 1, if we consider here in place of 2, 1 by 2 xt, then magnitude becomes 1 in the range of 0 and 1. This is the 1 beta. This is the 1. Okay, this is the 1. Okay, and that time if we multiply here by 1 by 2, 1 by 3, that is less than 1, then the signal we obtain is said to be attenuated version of original signal. Okay beta, this is the amplitude scaling. Now read beta each and every point. If mod a greater than 1, if mod a greater than 1 is yt is amplified version of xt. Okay. Next, mod a less than 1, attenuated version of xt. Okay beta. Okay. Yt equal to, this is the not comma, this is the multiplication xt. A equal to any constant. See, this is the key point. Y-axis value get multiplied by a, but time axis values remain the same. Okay. Slope get scaled by a, area get scaled by a. This is cleared by me in the next slide. Beta, please tell me this line is clear or not? This is the line beta. Tell me, this line is clear or not? Tell me. Beta, speed is clear or not? This speed is clear or not? Okay, Shodhan, okay. Okay. See again. This is the beta amplitude scaling. Next. And what is our topic here? Here we discussed operation on dependent variable like y. Okay. Here we not perform any operation on time, where time is the independent variable. This portion we discuss separately. But here we discuss only operation on y, that is xt, completely xt, not on time. When we perform operation on a time particularly, then these operations are said to be operation on independent variable. Okay beta, this is clear or not? What is the meaning of operation on dependent variable and independent variable? First of all, clear me. This is clear or not? Now next beta, next. This is why this is clear beta. Next beta, this is the example. See here. This is the example. This is the example. See. What is the original form? See. From -1 to 0. This is the beta -1. This is the 0 by default origin. Okay. And this is the xt. This is the xt. And this is the time axis. See, because here we study the operation on continuous time. And in operation on continuous time signal, we discussed operation on dependent variable, that is y or overall xt. Okay. See, this is the xt. Here we perform y equal to, here we write yt equal to 2 times of xt. See. So beta, the values on the time axis remain same. Okay. Only values on the y-axis multiplied by a. Here a equal to 2. Okay. So the value of that is 2. Then we multiply. This is the value of 2. When we get 2xt, then multiply this value by 2. Then this becomes 4. And what is the value of that? Minus 1. And this value becomes minus 2. Minus 2. Tell me, beta. Now, my question is that this is the amplitude version of that signal or attenuated version of that signal. Tell me in the comment box. Tell me. Tell me. Attenuated amplitude version. Beta Shodhan, what is amplitude version? Beta, okay. Amplitude, okay. Beta amplified na, not amplitude na. Amplified. Here we write amplitude. Check me. Amplified na beta, not amplitude. Amplified version or attenuated version. Okay. See. Now beta, amplitude scaling property is clear or not? Then this is the good way. Clearing all the theoretical things from the PPT. Are you comfortable for that? Tell me. If you not understand any topic, then we discussed by considering more example. Okay. Clear sir. वैभव HMM बहुत चलता है यार ये. चलो नेक्स्ट. सेकंड बेटा एम्पलीट्यूड रिवर्सल. एम्पलीट्यूड रिवर्सल. Amplitude reversal. See, this is the beta second amplitude reversal. What is the reversal of amplitude? See, when this is the beta key points. When a negative sign is placed in front of signal, we flip the signal about the time axis. This is the time axis or horizontal axis, and this is the signal value axis or vertical axis. See beta, what is the example? This is the simple thing beta. On the operation on dependent variable are very basic beta, very basic. See here, and I promise you operation on independent variable are also simple. Okay, see this is the beta signal and this is the value at, okay, here we consider minus 1, here 0, here plus 1, okay, minus 1, okay, here we consider 2 because this is the larger 2 and this is the time, okay, and this is the, okay, see beta, this is the signal. When we get Z, this is the xt, when we get new signal zt equal to by multiplying minus xt. This is the representation of amplitude reversal of any signal. See, if any signal xt, if we multiply minus of xt, then this is said to be amplitude reversal. But this is the amplitude reversal of that signal and vice versa. Okay, see, we deleted this. This is the beta original signal. This is the original signal. When we multiply minus on xt, here we see beta. This is the, we clear that. See, this is our example. If here we consider, see, yt equal to new signal y1t equal to minus xt or beta minus 1 into xt. This is also write this na, minus of xt we can write as minus 1 multiplied by xt. So on the y-axis, on each value we multiply by minus 1. Okay, then plus value becomes minus and minus value become plus. This is the beta basic approach. So now we consider our example. See, when we multiply -1 in that signal, then beta only y-axis values are changed. Which value lie on the y-axis or vertical axis? That is the amplitude will be changes. See, beta when we perform operation on the dependent variable, then only amplitude values are changed, not time, because we not perform the operation on independent variable, that is time. So when we perform operation on the dependent variable, time axis values remain same. This is the key point. See, this is the original signal, this is the modified. When we multiply -1 in that signal, then +2 become -2. Then signal become this -2 beta. This is -2. Okay. And -1 becomes +1. Then this signal becomes this. Then this is the amplitude reversal. In other words, we can say on the respect of horizontal axis, we take a image, mirror image. See, this is the image beta. This is the mirror and this is the object. Then what is this is the mirror. What is the image with respect to that mirror? See, we draw in this. This is the image beta. Okay, this is clear or not? Tell me. So when we take amplitude reversal of any function, then we flip the signal about the horizontal axis or time axis. Tell me. Mirror image with respect to horizontal axis. Yes, Anshu, you are right, beta. Deepika, yes. Beta, this is clear or not? Tell me. This is clear or not? Amplitude reversal is clear or not for each and every student? Okay, guys. Okay, next. Modulus. This is not module. This is the modulus. This is the modulus. Modulus operation. Beta, z equal to mod of xt. Mod of xt. Okay, see. Negative part of xt. Negative part of xt flipped about the time axis. See here. If any signal xt, see beta, any signal represent this. This is the 0, where we consider some value. This is the -1. This is the 0 and this is the -1 time axis. Value on time axis. Here we consider -1. This is the value of 1. When we take modulus of that function, this, then the positive value remains same. Positive part remains same. This is the positive part 2 and this is the 2 time axis. Then what becomes a negative part of xt becomes also positive because modulus of xt. Then this becomes like this, and this is the value of 1 and this is the -1. This is the time value and this is the function value beta. Okay, this is the mod of xt. Okay, this is our example. Okay, next beta. Now this is the negative part of xt is flipped about the time axis. Flipped means, okay, make it positive. See beta, this is our example. This is beta xt, this is the -1, okay, and this is the +2, okay, and this is also +2 and this is -1. See beta, when we take modulus of that signal, then beta -1 to 0, this is the value of signal is -1. Then when we flipped about the time axis, then it becomes like this, and 0 to 2 signal is triangular and the value of 2, then this becomes same beta because this is the already positive na. Okay, this is the already positive. Okay, we write here so that you cannot confused. Okay, this is value. Okay, okay beta. Tell me beta, modulus of any signal. Any doubt? In the modulus of any signal, any doubt? Deepika? Okay, clear sir. Shodhan, clear. Anshul, okay beta, okay. Vaibhav Raj Singh, okay beta, okay. Next. Next perform beta addition and subtraction of constant. See beta, in roughly. If any signal, here we discuss some example. See beta, if you carefully listen me, then all the doubt will be automatically clear. See, if any signal xt is present, or we having any signal xt, any signal, any format. Okay, see, when we multiply some scalar like a, okay, then signal shift upward, vertically upward by a amount. If a equal to 2, then signal shift upward by 2 amount. Okay. If a equal to 3, then signal shift upward by 3 amount. If a equal to 3. See. If xt minus a, then signal shift downward vertically. Okay. Vertically downward by a amount. If a equal to 2, then it shifted downward by 2 amount. Okay. This is the basic meaning of addition and subtraction of constant. Okay beta, this is the basic meaning of addition or subtraction. When a positive constant is added, then signal shift upward. When a negative constant is added, then signal shift downward. Okay, here we consider some example. Xt plus a, here we write xt plus minus a, or we write as xt minus a. Okay beta, here a is a positive number. Okay, like a equal to 2, then signal downward shifted by 2 amount. This is clear beta. Now we consider an example. Here we consider one example beta. This is the our signal and this is the minus 1. Here we correct the value. This is the minus 1. Minus 1. Okay, minus 1. Okay, this is the beta original signal. This is the 2. When we add 2 in that signal, then signal shifted upward by 2 amount. Then this is the origin. Then this becomes, when we add 0, when we add 2 in 0, then it becomes 2. See, it becomes 2. Okay. And this is the value minus 1. This is the value minus 1. When we add in the beta, when we perform the operation on the dependent variable, then only magnitude will be changes. When we add in minus 1 plus 2, then it becomes plus 1. So it becomes plus 1 beta, like that. But here is okay. And this is the beta, this is signal is like that. We draw like that beta, so that you understand easily. This beta. This is the way. This is the signal original. Okay. See, when we add 2 in minus 1, then between minus 1 and 0, signal becomes beta plus 1. And beta minus infinity, this is the minus infinity and this is the minus 1. When minus, between minus infinity and minus 1, when we add 2, then it becomes, sorry, this is the 0 value na, this is the 0 value. Then between minus infinity and minus 1, we add 2, then it becomes 2 beta, because in between minus infinity and minus 1, signal is already 0. When we add 2 in 0, then it becomes 2. That's why beta this is 1. Sorry, this is the 2 value of the signal. Okay, we draw here dark this beta. Now next beta, next. When we add in this beta, first of all we break the signal in multiple parts, like minus infinity to minus 1, minus 1 to 0, 0 and 0, and this is the 0 and 2. So here we consider 1 beta. Here we consider 1 value. Okay. So in between minus infinity and minus 1, signal is 0. When we add 2, then it becomes 2. In between minus 1 and 0, the value is minus 1. When we add 2 in that, then it becomes 1. Then this is the beta minus 1 and 0. The value is 1. Next, this is the value is between 0 and 1, signal is 2. When we add 2, then beta all y value changes, then 2 becomes 4. This is the 4 beta, and this become beta, first of all is 0, this become 2. Okay. Next beta, this is the 0, this become 2 beta, like that. Okay. this. Tell me beta, if it is clear then tell me. Beta, adding or subtraction is clear or not? And next beta, this is the xt minus 2. When we subtract minus 1, see beta, this is the minus infinity and this is the minus 1. Between minus infinity and minus 1 signal is 0. When we subtract 2 from the 0, then it becomes minus 2. So minus infinity and minus 1, between minus infinity and minus 1 signal becomes minus 2 beta, this like this. Okay. And between minus 1 and 0 signal is minus 1. When we subtract 2 from the minus 1, it becomes minus 3 beta. That's why between the, this is the minus 1 beta, minus 1. Okay. And this is the 2, this is the 1 and this is the 0. Okay. But all the points clear? Please tell me beta. This subtraction, when we subtract anything, any constant value from the given signal, then it shifted downward, otherwise beta upward. Tell me. Tell me beta. Harshita.
Sir, on what basis that amplitude value is written as 3? It should be in the previous example, sir.
In the previous example, tell me beta again. Not beta amplitude, na? Not amplitude.
There, after x of t plus 2 conversion, you have
If
noted
you
as...
confuse from that value, delete beta this. Okay. This is the typing error. So delete this value. Okay. Now tell me.
Okay, sir. Clear, sir. Thank you.
Okay. Okay. Harshita SK, sir, can you explain again? Which point beta Harshita? Tell me. Which point? Clearly tell me beta. Harshita beta, come on, audio feature. Addition and subtraction of constant. See beta, here. Beta, here we perform the operation on dependent variable. If any constant, this beta, this is our basic example. This is the xt original signal which having, okay. When we add some constant on that signal like a, then signal vertically shifted upward by a amount. If a equal to 2, then signal is shifted upward vertically by 2 amount in the magnitude only beta, because here we perform the operation on dependent variable only. Okay. This is the beta example. When a positive constant is added, then the signal shift upward. When the negative constant is added or we subtract any positive number like that, then the signal shifted downward beta. This is our example beta. This is the original signal and this is not the delete beta this. Okay. So that you not confuse. Okay. See beta this. Harshita. See beta again. Beta, this is the signal. This is the value of the signal from minus infinity, between minus infinity to minus 1. And what is the value of signal? 0 na beta. This is the 0. This is 0 na. When we add between minus 1, minus infinity and minus 1, 2, then this 0 becomes, when we add 2 in 0, then it becomes 2. Then between minus infinity and minus 1, signal becomes 2 beta. This is the 2. And this is the time instant minus 1. Between minus 1 and 0, signal is minus 1. When we add minus 1, when we add 2 in minus 1, then it becomes plus 1. That's why between minus 1 and 0, signal becomes plus 1 beta, like that. And beta, this is the value 0. And when we add 2 in 0, then it becomes 2. This is the 2 beta. This is the 2. And actually, this is the value beta. This is value like, this is the in something that. Yes, this is the same value beta. This is the, this. Okay. Next beta. And this magnitude into, when we add 2 in the signal, then it shifted upward 2 amount, then it becomes 4 beta. Okay. And after time 2, signal is 0. When we add 2, then it becomes 2. Harshita, tell me beta. Tell me beta, Harshita, is it clear or not? Yes sir, clear, thank you. Okay beta. Now next. And this is the beta subtraction. See in similar way. Now beta, operation on independent variable. Operation on independent variable. Now beta, from independent variable we discuss tomorrow, okay? Because health issue, okay? Today class is only up to here, okay? Now beta, please tell me, this speed is okay or we increase the speed? Frankly beta, tell me, this speed is okay? Harshini B, okay. And beta, only those things which are theoretical, okay, which take the more time when we write here anything, and when we use this concept in the live class, then beta not possible. In the given period of time we covered all the things like in network analysis, okay? So that we use ppt for the theoretical things, and for the derivation and important formula and questions practice we use handwritten, okay? If anyone having doubts regarding this way, then please tell me, so that we understand the problem of each and every students. No problem na beta? Okay beta, okay. Now beta, this is the class of today. Now we take your doubt, then please tell me what is your doubt in today class for 2 minutes, so that each student, because beta today is the first lecture of signaling system. Tell me. Shodhan, no doubt sir. Ashwarya, you are new student beta. Beta, how many students are new? Who's study with the signaling system? Starting the study with the signaling system. It was nicer understood. Thank you. Okay, Harshini. Tell me, how many student here who start the preparation with the signaling system? No. Okay. That's good. Okay, beta. Okay, Atharv Dhumre. Okay, beta. Anil. Okay. Okay, beta. Then if you having any doubt, then you DM me, or we connect you via WhatsApp for any doubt beta, okay? Live class or conceptual or any examination preparation guideline and all, okay? Then this is the today session, okay? Okay guys, okay, thank you.